Now, if our indices are higher than 2, for example, I have cube roots in both of these, well, we can still deal with this problem as well. First of all, notice I have a cube root of 16, take away a cube root of 54. Those are unlike terms, so on its face, I can't simplify or combine, but maybe I can simplify first. So let's see if we can refactor or look for the factors of the cube root of 16. How can I factor 16 such that one of its factors is a perfect cube? Well, what are those cubes again? Well, 8 was 1. 8 is a perfect cube. How do I factor 54? 27 is a factor, and that's the greatest perfect cube that factors into 54. Rewrite these out. So it's 2 times the cube root of 8 times the cube root of 2 minus 4 times the cube root of 27 times the cube root of 2. So I have 2. Cube root of 8 is a 2. Cube roots of 2. 4 times cube root of 27 is a 3. Cube roots of 2. You can see how you have to be real careful and not get lost in some of these. There's going to be lots of 2s, lots of 3s popping on up. And if you're not careful, you're going to lose track of what's happening. 2 times 2 is 4. So I'm left with on the left side 4 cube roots of 2 minus 12 cube roots of 2. Now I can ask myself, how many cube roots of 2 do I have? 4 take away 12, I have a negative 8 cube roots of 12. Another one, we're looking at cube roots. Let's look at both terms and see if I can combine right away. This one is cube roots of xy squared plus cube roots of 8x to the 4th, y to the 5th. Unlike roots, I cannot combine, so I'm going to look to see if I can simplify. The left side, are there any perfect cubes in xy squared that I can factor out? I don't see any. However, on the right side, I do. So on the right side, I'm going to rewrite it as the cube root of 8, x to the 3rd times x, y to the 3rd times y squared. And on the left side, I still just have 5 cube roots of xy squared. Pull out all my perfect cubes I can find. So the cube root of 8 is a 2. Cube root of x cubed is an x. The cube root of x is just a cube root of x. Cube root of y cubed is y. And the cube root of y squared is y squared. On my left side, I still just have 5 times the cube root of xy squared. Now I can ask myself, do I have both terms? Can I add them? I have cube roots of xy squared plus cube roots of xy squared. So I'll have 5 plus 2xy cube roots of xy squared. My final result right there. Notice I can't combine the 5 and the 2xy. Those are unlike terms, but both of them are multiplied to the cube xy squareds.